Good morning, good afternoon, good evening, wherever you are joining in today from. Hello everyone and welcome to Nalasha Solutions BI webinar for the aviation industry. Hi, this is Deb from Nalasha and I lead the sales from the analytics business unit. Today's webinar we plan to cover business intelligence, what it means and its importance and impact on the aviation industry. We would walk through some dashboards covering both reporting as well as predictive analytics. For our dashboards and demonstrations, we have used Microsoft Power BI to create interactive dashboards. We have used public data sets from US Department of Transport, Bureau of Transportation Statistics, and other public data sources for engine performance data and similar sources for other data streams that we have used in our demonstration today. So during the webinar, we have a few polls that we have slotted in between, and we would request your active participation in them. The way the webinar will run is all the attendance will be muted initially, but you can type in your questions during the webinar, which will be captured and answered at the end of the session. And during the Q&A session at the end, you may raise your hand on the webinar window and you'll be unmuted and you can interact with various questions and your inputs and opinions. We look forward to that. So we look forward to a very interactive session at the end of the key presentation today. So without much ado, let me introduce our speakers today who come with considerable experience in business intelligence background. First, let me introduce Sandy. Sandy is passionate about technology and he loves solving technical problems. He is an experienced on working on a wide range of technologies covering embedded systems, operation systems internals, different types of databases, and the latest web technologies. At Nalasha, Sandeep heads the delivery teams in enterprise, business intelligence, and robotic process automation. Our other speaker, Sushant, is one of the experts in the business intelligence solutioning. He is a lead data engineer at Nalasha with more than 9 years of experience in BI solutioning both on-prem as well as on cloud environments, and is actively involved in implementation and performance tuning. He has worked in various domains, of which aviation, supply chain management, retail, and telecommunication are some of the key areas wherein he brings in his depth of knowledge. So I think it's the right time for me to hand over to Sandy and Sushant for the webinar, and I wish all the best to all the attendees and I hope you have a very good session going forward.
Good afternoon all, this is Sandeep here and I'll be taking over the presentation from Deb. Thank you Deb for the nice and crisp introduction. So this is going to be a very interactive session with a lot of polls coming in between the presentation. So to start with, let me just start with the big or a very, very high level definition of business intelligence. There are various definitions that are there. One of my favorite that I've quoted here are, it goes like this. Business intelligence is a collection of decision support technologies meant for enterprise, and they're aimed at enabling knowledge workers such as executives, managers, and analysts to make better and faster decisions. This is as far as one of my favorite definition goes, but to be crisp and concise, what does it mean to a business? The business intelligence does have the business part of it, so what does it mean to a business? In simple terms, all we are trying to say is business intelligence is a way of providing accurate information to the right people at the right time so that they can make effective decisions. Here, the key emphasis is on having accurate information provided to the right people in a timely manner so that they can take effective decisions. So at a high level, this is what business intelligence is, and that is what we are going to talk about in the presentation. When we talk about business intelligence, it covers a huge field. There is a lot of stuff that are happening. So when you talk about business intelligence, what is the maturity model? What is an organization's maturity model? Where is it in the entire BI space? So to start with, it's the pure basics of business intelligence with a low maturity model, where what the business does is stores all the historical information with which they can answer the question, what happened here? So they take the help of this historical data and understand what happened, why did, how did this happen, and so on and so forth. So that's a low maturity model for business intelligence. Moving on, as we get more data, moving on to up the value chain and the maturity model, we get into a space of why. That's the next stage of implementation, when people can ask, how are we doing against the plan? How are we doing against the threshold? What is that we can tweak to hit our target? We are here now. From the current trend, I don't think we will be able to meet our targets. What is that different thing that we need to do to hit our targets? So this is the medium level maturity of business intelligence. If you look at the Venn diagram, it is at the intersection of these two. And at a very high level maturity, you have a business asking, what next? That is where the predictive part comes into play. At this stage, you have advanced analytics and predictive modeling. These are added into the business intelligence to anticipate future events. That's when, the business can ask and answer the question, what will happen next? And how can we optimize the outcome? Building an organizational BI maturity is a journey, starting from helping organizations store, collect historical data and make decisions based out of them. And from the historical data, move up the value chain of BI to anticipate and to respond to future events in real time. So starting from simple historic data analysis to the prediction is the entire gamut of BI implementation, and the ROI increases as we move up the value chain. There is another aspect of BI, the most visual aspect of BI, because most of the things that happens in BI is in the back end, behind the scenes. But the aspect of BI that is clearly visible are reports. Reports are nothing that is specific, or it's not that they came into being because of BI. We have been having reports in existence even before we had computers. And they were reports that were text or grid based. However, with the development in the user experience technology, the grid based reports are a thing of the past today. With the advantages and capabilities of visualization, the textual reports are a thing of the past today. And the advantages of the visualization over the textual report cannot be disputed at all. Today's tools actually combine visualizations with various user interactions and natural language querying to take reporting to the next level. The technology in the visualization space and in BI has matured so much that we can put together an interactive dashboard within a matter of a few weeks and deploy it live, so that the business can start using it and start seeing the ROI on top of it. When we talk about BI for aviation, before we get there, we need to understand the various systems that are there as part of the aviation space. So there are various systems addressing specific needs, and these systems are ranging from ticketing systems, fleet management systems, CRMs, your ERP, it could be your vendor management system, or the aircraft maintenance systems, or the crew management systems. It could also be airport IT systems. So each of these systems seamlessly perform their own functionalities, and they have their own internal database. There is some interaction between these disparate systems, but that is very, very limited. Given that we live in an information world, it is imperative that we harness the capability of the data that is available within each of the system. We need to combine the data, mine the data to get more information to drive better business decisions. There are few problems with that. So these challenges are, one is the data might not be structured within these systems, or the data is semi-structured or unstructured completely. Also, we have centralized systems within a different organization, be it our vendor or the airport. So we would need to tie all these systems together, pull the relevant information into a data warehouse or a data mart, and work on this particular data mart to get good visualization or reports out of this system. And today we have systems that are capable to deliver this into a laptop or into a mobile or any other platform of your choice. So that is how we can envision BI can be used in aviation. What are the areas within aviation where we can use the BI? What are the functional areas that we can? And why should we use BI in aviation, for that matter of fact, in any industry? So every business today has the same problems. If you look at it deeply, it is it all boils down to a simple points like the capital costs are raising, operational expenses are raising, the customer demand is decreasing, and then there is constant pressure from the management, from the shareholders to increase or maintain profitability. These challenges are omnipresent for every business, which is also true for the aviation industry. So using BI, leveraging or hedging with the data that they have with various systems, they can drive better decisions across various functions. For example, they could, let's take an example of sales and marketing. Sales and marketing can use their existing data to see what is the next channel for promotion. Are they going to promote it on mobile? Are they going to promote it on big hoardings? Or are they going to promote it through emails? So using big data, they can actually identify the channel which is going to give them a great result rather than trying out all the other platforms. Similarly, if you look at operational awareness, so BI can help the management to take better decision, identify the crew, assigning the right crew to the right type of aircraft, anticipating maintenance and planning maintenance ahead of schedule, planning routes according to the maintenance need. So these are some certain small things that go a long way in terms of operational awareness. Customer experience or the passenger experience, ensuring that the flight status information is disseminated in a timely manner, reports into the baggage information. All these go a little extra to help build the bond with the customer. Then taking the BI to the next level of predictive analysis, where it can be used to model pricing, look at different models, identify the trends, and then price accordingly or run promotions depending on the demand or the peak load. All these things can be done using analytics and certain data models which help strategize the next steps for an airline. I just want to quickly jump into a few sample dashboards that we have done. So as I was saying, the BI can be used to help airlines in various functions. We have created a sample dashboard for the aircraft maintenance and the engineering division. So in our dashboard, it gives a quick health of each of the aircraft that are available in the fleet. For example, if we look at the left topmost chart, it talks about the fragmentation or the different types of aircrafts that are there in our fleet. Then there are mandatory checks that are required for all planes. So there is this graph that talks about what is the kind of maintenance that needs to be done. For example, I can select a given month. Let's say interact with this graph. Let's say let me select May. So and then quickly, I get all the latest information that is applicable for the month of May. So I see here I have Airbus 340, 10 of them that needs maintenance. The user can actually interact further, go deeper into it and take a look at the information that is embedded in the graph. So for example, here I know the flight with the tail number IA006 is due for its maintenance check on May 2nd. So based on this, the maintenance team can actually take certain decisions, plan the flight routes and the maintenance activity accordingly. The other thing is the inventory, which also comes under maintenance. This Cortana graph actually shows the expiry of various parts that are available in our inventory. So the engineer can actually look up each of these fields. For example, he can go into each of these items. For example, similar to what I did earlier, let's say in the month of August, I would like to see what are the various items in our inventory that are going to expire. So I can quickly take a look at it and say there is one item that is a fan booster that is going to be expiring in the month of August. So I can plan accordingly, either by reordering the part or do certain life upgradation for that part and ensure that there is no minimum loss for the airline. And in today's world, as we are connected, there is a map that also can be showed on a dashboard. What we have mocked up here is the various maintenance hubs and their availability. So as a service engineer or a maintenance engineer, I can plan the activities of maintenance. For instance, I have a 747 somewhere in France, but it needs to be maintained. But there is no availability for a 747 in France or in the Europe region. So what I can do is I can take a look at our other operating hubs. For example, we have one in Singapore, one in the US, Chicago. So he can take a look at it, see its availability, and book the maintenance schedule for that flight there. So that way they can plan ahead and ensure that there is minimum impact on the business. We've also mocked up another graph here. This is about maintenance cost by aircraft. Basically, this shows the trends of what was the maintenance cost for different type of aircrafts in our fleet. So in the previous year to this year. So a quick glance can actually help the maintenance team to understand the amount of money that they are spending, whether it is beyond a certain threshold. If it is beyond a certain threshold, they can take a look at it and take corrective action to see that it's bought within the threshold value. We have another type of graph that is the ticker that is scrolling down here. This shows the next items that needs to be needs to come under the attention of the service engineer. So in this particular case, it is showing the aircrafts that are due to be maintained in the next period or in the next cycle. Apart from this, as I've been talking from the initial slides, the graphs are very, very interactive. If you can see, the snapshot that I've been seeing it for is for an entire year. I can quickly look into a different quarter per se and plan my budget, plan my personnel, so on and so forth. So this simplistic dashboard can help capture a lot of information for the maintenance and the engineering division. I have another graph or dashboard that we have created. This goes more into the predictive side of things. The previous one was on the historical data analysis, but this dashboard talks about predictive analysis. We have used the binary tree analysis and the multi-class data model here. So the idea here is that we have picked up the various sensor information that was published in the NASA website to identify different parameters within an engine. So the parameters and the faults within an engine. If you look at it, the fault count, which in each of the different components in an engine is listed here. The information is being constantly fed through our data stream, and depending on that, the data is modeled, and the various threshold values for an engine, this is the engine number here, is being plotted here. So green is something that is healthy, yellow needs some checks or warnings, and red is below a threshold value. So when we see that the engine number 7 has an issue, basically the model predicts, depending on all the faults that it is seeing, it predicts that it needs to be checked up and it is due for maintenance, because this black bar is already moved onto the red zone. So the maintenance team, what they can do is select that particular engine and see on which aircraft it is currently available and where is that aircraft. So it is linked to the map, and according to our information, it is there in London. So what the engineer can do is reach out to the staff in our London office, explain them the situation, have them run various tests on this engine and take corrective action. This is something that was done through predicting and modeling all the various faults that were there in this engine using the binary tree and the multi-class models. Okay, moving on, let me just quickly come back to the historical data set. This is another dashboard that we have created that talks about price versus availability. For the sake of this demo, we have assumed that our original location is London, and the planned departure date is 15th of July. And when at this moment at 100% availability, the base fare, let's say we want to travel to DXB, so the total fare would be around $150, with the base fare being $110 and all the other additional items here. So we could quickly run various scenarios. For example, see what happens if at 80% availability. So we can see that the price has increased, the base price has increased by a little extent, the debit card fee has increased, so on and so forth. So with such analysis, what a customer can do, what an airline can do is look at the different availability and model their own pricing strategy and come up with various plans for their ticketing systems or their ticket pricing systems. So this was all about the pricing and the availability prediction and modeling part of it. So I have moved on to the next dashboard. This talks about the flight operation and the route analysis. So when we are running an airlines, it's very important that we keep our eye out for different routes. So on my left bottom corner, I have this graph that plots the profitability of various routes. This in fact shows the top 10 profitable routes. So it's a quick dashboard for the executive suite to keep an eye on the performance of each of these routes. And also we have plotted the customer satisfaction across these routes. So what they can do is keep a constant lookout for these values and see if in our profitable routes the customer rating, if they dips or if there is any issues, they can quickly take a look at it, understand the issue, and then do a analysis and then see how we can get the customer rating back up to a considerable or a desirable level. We have this Cortana graph. This talks about all the routes that we have and our most profitable routes. So as you can see, my DXB to Sydney is my most profitable route, which is the same case here. So with this, they can keep a quick bird's eye view of various routes and their profitability. In flight operations, like in life, things can be delayed or sometimes even canceled. So in airlines industry, it happens due to various reasons. Most of the times it is due to reasons that are beyond our control. In certain cases, it is something that can be controlled. So the top 10 cancellations that have occurred, the top 10 delays that have occurred is a continual graph that can be updated on the dashboard so that the higher management can keep a check on it, identify a pattern in it, and see what can be done to reduce or keep these values on a minimum. As with all the other dashboards that I had shown earlier, the user can interact with each of this individually, and the graphs actually change as the user interacts with the dashboard. This is another Cortana graph that we have done. This is talking about the user satisfaction or the customer satisfaction that we got as a feedback from the various routes that we have. Depending on what are the thresholds that each airline has, we have a good, we have a bad, and a okay. So the key people can keep an eye on this and identify what are the routes where we have too many problems. For example, here we have IA008, it isn't bad. They can take a look at it, the information, interact with various tweak certain parameters and see how it can be improved, why the customer felt that the service was not good, and then they can take certain corrective actions to ensure that the operations and the customer satisfaction is back to certain thresholds wherein it can be managed better. So this was about the flight operations and the route analysis. Most of the dashboard that we saw until now was internal to our systems, to a single airline. It is also important to benchmark our airlines against our competitor. So what we have done in this particular dashboard is used information that was available in the public domain. So we had certain information from 2003 to 2016. So a quick analysis can be done in terms of, for example, we can take a look at Alaskan Airline in 2007 during Christmas, in the month of December. What was their, yeah, it's loading, give it a minute, yes. So what was their load factor? It was 77%, 73%. What was their international load factor? It was 72%. What was the seat miles that they had? It was 11,657K, so on and so forth. So with this, what the management can do is they can, work around with various parameters here and then identify what routes are profitable, what are the routes that we as a company need to compete, and take decisions according to it. This was all about the competitor analysis part of it. Moving on to the next dashboard. So we spoke about, until now, we have been talking about most of the items that were in the air. The other important factor happens in the customer experience is when they are in the ground. So we identified, let's take a dashboard about baggage handling, because that's one area where a lot of inconvenience that happens to the customer satisfaction drops if there is a loss in baggage. So this is a dashboard that is available to the relevant teams, wherein they can take a look at what are the baggages that were lost over a last period, for example, over the last 1 week. So in this case, we lost around 514 items. So how many of those were found? We were able to locate 244 and then deliver it to those customers. However, we could not identify around half the other baggages that were lost. So we ended up paying compensation of 22K. So these snapshots are available in the dashboards. They can quickly take a look at it, and then we have another graph that talks about which is the particular route where we are facing a lot of baggage losses. So if I see SEA to DXP is one such route where we are having a lot of lost baggage, and we ended up paying good amount of compensation there. So what the management or the relevant people can do is take a look at this information, work with the relevant teams, identify the source of problems, and take corrective steps, and then come back and look at this information again and continue until the entire operation improves, or which in turn improves customer satisfaction, and that in turn improves the overall profitability of any business. So there are a couple of other graphs that we have here. The Scout on a map represents the various baggages that were lost. For example, LAX to JFK, we lost around 27 baggages. So these graphs are also interactive, as were all the other dashboards that I showed. So this is a dashboard that talks about baggage handling, the kind of statistics that goes behind it, and this helps them to drive better business decisions. So we have noticed that any successful implementation of BI goes through 4 different steps or 4 different phases. The first one is gather data, then we extract and cleanse the data, we build a data store, and then we build a visualization. Various tools are used in each of these phases, and they are not, for example, in the gather data phase, it's purely analyzing the line of business applications. So we would be using documentation or mapping tools to map the databases, analyze them, and analyze the requirement in that particular phase. In the extract and the cleanse data phase, we use tools like SSIS from Microsoft, Talend, Pentaho, and if we have our plans to implement our solution in the cloud, we can even select Azure Data Factory here. Once we have extracted, cleansed the data, we need to store it somewhere so that it can be easily pulled by the visualization. So there in the data store step, we use Microsoft SQL Server, MySQL, or if we are looking at cloud solutions, we can look at Azure Data Warehouse or Cubes. And once all this is done, we have to show the reports. So there are powerful tools like Microsoft's Power BI, ClickQ, and Tableau. These tools, what tools is used in what step, it depends on a lot of factors. It depends on the capability, it depends on the requirement, it depends on the number of users, it depends on the features that we are looking at. So based on all this, we do a trade-off and we recommend the tools that needs to be used in each of these steps, and then we help you build the solution. Coming back, Nilasha's offering. What can Nilasha offer in this BI space? We provide solutions in all the steps that I mentioned earlier to enable a successful BI implementation. In the gather data phase, we help you analyze and identify your data sources. These data sources are not limited to the following that I mentioned: the operational database, it could be your ERP systems, it could be your CRM systems, ticketing systems, partner data, vendor data. It could also be public data sources for competitor data, social media, etc. And this particular phase is a purely requirement analysis phase and a documentation phase where we identify, document, and analyze your data sources. And then we help you in the extract and the cleanse data phase where we pull all the information from the data sources that were documented earlier, and then we extract the relevant information from this database. The most common question that we are asked by our customers is, why do we have to extract the data? Why don't we use the data as is? The first thing is we cannot use the line of business or the operational database because that will introduce certain performance lag in the operational applications. Second, the information that is there in those operational database is purely structured for the operational business or operational features. So for visualization, for reporting, the data needs to be in a format that is friendly for querying. So we pull those data, take a subset of data and store it. Also, the volume of data that is there in the operational database is very huge. So if we pull all the data, the replication costs are high, the storage costs are high. So factoring all this, we pull out only a subset of information that is required, cleanse that, sanitize this data, and then move it into a data store. In this stage, what we do is we transform the data and load it into a data model or a warehouse. This is where we inject predictive modeling and machine learning in this particular phase. And all the information gets pushed on to the visualization where the actual end user interaction takes place, where the user can look at the interactive dashboards, do natural language queries, and interact with the reports. So this, as mentioned, we support end-to-end business implementation of BI. And thank you, and that's all I had from my side. Quickly summarizing whatever we spoke about, we started with the basic definition of BI, various levels of maturity of BI in an organization. Then we spoke about different types of reporting and how reporting has come or metamorphosized itself into visualizations today. Then we spoke about the different systems that are used in the airline industry. Then we spoke about what are the areas where BI can be helpful in the airline or the aviation industry. Then we spoke about, we looked at a couple of dashboards in various functions within an airline, and then we spoke about the different stages or steps that are there in successful implementation of a BI in a given organization, and for that matter of fact in the airline industry. With that, I close my webinar. If there are any questions, we would be happy to answer that for you.
Hi, my name is Rahul, and I was curious to know about the models you use for predictive analysis.
Thank you, Rahul. That's a good question. Currently, what the model that is being used depends on the requirement and also the functional area that we are looking at. And at this moment, Microsoft does support around 6 predictive models. In the demo that we saw, we used 2 models. One was the graph tree, and the other was the multi-class data model. So these were the 2 models that we have used, but depending on the requirement, depending on the industry that we are talking about, we could identify more statistical models that are available and implement predictive analysis.
Thank you, that answers my question.
Thank you, Rahul.
Hey guys, this is Anuj, and my question for you is, how does Power BI perform against other BI tools?
So that's a good question, and that's something that we keep getting asked in most of our customer interaction. So Power BI is from Microsoft. I think it is a pretty later entrant compared to the other entrenched players of Tableau and ClickView. From a features perspective, I don't think there are any differentiation at this moment, and Microsoft is continually evolving the Power BI product. In fact, every releases of Power BI comes with Power Packed and better infrastructure and more features as we speak. Uh, the key area where Microsoft is trying to compete with others is in terms of the cost. Power BI is relatively cheaper compared to, in fact, very, very cheaper as opposed to the other tools at this moment. I don't think there is any specific advantages or disadvantages or something that can stop somebody from using Power BI in their implementation. I don't think so. I'm aware of it at this moment at least.
So before we move to the survey, let me just convey my vote of thanks to Sandy and Sushant for your time today. That was a very, very informative session, and hope all the attendees had some key takeaways from this webinar. We'll be sharing the webinar recording link for your reference, and we'll be ending this with a survey that if you can please finish off, that would be great and very much appreciated. So thanks and have a great day ahead. Thank you very much.